We have finished almost circle properties. So you are familiar with the question? Find angle ADE. ADE. Okay, this is the angle over here. Usually for EMATS, they start off with quite simple questions. Typically 1 mark each because it is straightforward. So looking at the diagram, we see that we've got angles in the same segment. They all start and end at points A and they end at point E. So these are corresponding angles. Remember this butterfly shape that I told you about? So when we see that, we know that we can apply angles in the same segment. So ADE 62 degrees. Please run out of reasons. They even tell you, they specify. So if there are no reasons given in your work, you do not get a mark. So it is a huge waste, especially if you know how to do it. So you need to memorize it because you have to give the correct explanation. Okay, next, AEB. Okay, identify angle AEB. Okay, this is the angle over here. To find this angle, we make use of the property that BE is the diameter. If B is the diameter, it means that it is a semicircle, then angle EAB has to be 90 degrees. And we write that down as angle EAB equals 90 degrees. Reason angles in semicircle. Only then we move on to find the required angle. Angle AEB will be 180 degrees minus, label down the angle EAB and minus away the other angle ABE. State your reason. So over here we have angles in angle sum of triangle. So these are explanations that you have been learning since Sec 1. If you had memorized it then, right now it will just come out of you naturally already. Because you've been practicing it for 3+4 years. If you haven't memorized them, now you better start memorizing so that when it comes to O levels, when it comes to your prelims, your job is much easier. Do the substitution, 180 degrees minus 90 and minus 62 degrees, we end up with 28 degrees. Finally, BAD. BAD. This is the last required angle. Always look out for quadrilaterals inside a circle. Okay, besides this shape, you also have to look out for the butterfly shape. That will be our angles in same segment. So in quadrilaterals, which is commonly missed out unfortunately, we can compare the opposite angles because they add up to be 180 degrees. These are known as angles in opposite segments. So for the last one, angle BAD will be 180 degrees minus, name the other angle, BCD. State the reason before you calculate. Angles in opposite segment. Do the substitution and we arrive at 70 degrees. Now, next, part 2, part A, find angle BFD. BFD. Now we need this angle. There are a few ways we can do this. The most straightforward way is to recognize that it is the exterior angle of this green triangle. Right? So one way we can do is to find the angle sum of this triangle, 180 degrees, find out the last missing angle, then adjacent angles on a straight line, 180 minus the last angle in a triangle to get the answer. Or we can do it straight away by adding 70 and 62. The reason will be the sum of interior, sum of the interior opposite angles of the triangle. So one calculation, one reason is sufficient. Of course, if you want to find out the unknown angle in the triangle, then adjacent angles on a straight line, fine, go ahead. So we will have this angle as the sum 132 degrees. Last one, angle DBC. DBC. This is our last unknown angle. Notice that we haven't really used our parallel lines yet. I'm not sure whether we'll be using them anytime soon, but here we earlier mentioned that this is 90 degrees. Right? Angles in a semicircle. If this is 90, this has to be 20. If this is 20, then we identify another butterfly shape. I'll highlight it out for you. Okay, so here we have angles in the same segment again, another 20 degrees here. With this 20 degrees and making use of parallel lines over here, I know that the interior angles have to be 180 degrees. Interior angles, parallel lines. So state that as the reason, which means that this angle has to be 70. 180 minus 110, we get 70. Take away the 20 that we found out earlier, and this will be 50 degrees for the last one. Okay, state all your reasons accurately. So that's for part A, for your circle properties. For part B, to find the volume of this prism. Volume of a prism is always given by area, the cross-sectional area multiplied by the perpendicular height. Cross-sectional area, since this is 76 degrees out of 360 degrees of a circle, pi radius 6 squared. What I've just written over here is the cross-sectional area. We're going to have to multiply this by the perpendicular height, and this will be our volume. Of course, leave it to 3SF since pi is involved. Okay, the next one. 6B, part 4. State what the elements of P represent. Matrix question. Stating what elements represent. It is almost a given that this question will always come out. When they give you matrices, you can be sure they will test you on matrix multiplication. If they test you on matrix multiplication, they will want you to explain what the elements represent. So the strategy to do this, after you have written down your matrices, okay, this is in part 3, where you were evaluating. Put in the headers. Just copy them down. AM, PM. So due to a lack of space, boys and girls, let's just put it at the side. Boys and girls. Okay, this is the header, not difficult. Move on to the other matrix. Your 3 and 2.5. They refer to money, the fees. Both of them are fees. Now the 3 over here represents morning session. So you can call it AM also. The afternoon session, PM, 2.5. So PM over here. We recall that when we do our matrix multiplication, the first matrix is a 2 by 2. The second matrix is a 2 by 1. Our resulting matrix is going to be 2 by 1. So effectively, we are cancelling away these two inner values. We do the same for the headers. You see the AM, PM that appear twice, cancel them away. When you cancel whatever is common, we are now left with boys and girls, and the only other header that is left is your fees. So this is what the elements represent. Boys, girls, and fees. Matrix multiplication involves addition. So we will expect keywords such as total. Expect keywords such as respectively. Okay, so these are two keywords that should almost always be in your explanation as to what the elements represent. So in this case, the elements in P represent the total fees collected for the boys and the girls respectively. Standard way of answering. Okay, question 7. Now I need all of you to look up. Question 7 on graph. 陈卓, look up. I'm interested in part C. Okay, you have plotted a graph already. Your equation of your graph is given as such. They ask you to use your graph to find the solution to another equation. It's a very familiar question. Our objective is to manipulate whatever is given for the equation, manipulate it back to what we already have, the equation of the graph. So we start by copying down what was given in part C, x cubed over 20 plus 10 over x equals to 5. Manipulate this back to your original equation. I see a x cubed plus 20 and x cubed over 20 plus 10 over x. But I need a minus 5. Okay, so x cubed over 20 plus 10 over x, I need the minus 5. So if I minus 5 on the left hand side, I also must minus 5 on the right hand side. So the next step, x cubed over 20 plus 10 over x minus 5 equals to 0. Now, we see that this is part of our graph. To complete it, our graph says y equals to whatever this is. Let's just complete it. Y equals to whatever that is. Right? This is our graph that was plotted. Now, we see that on the right hand side equals to 0. So y equals to this. Y must also be equal to 0 because all of them are equal. In other words, we have to draw the graph of y equals to 0. Now, what is the graph of y equal to 0? It's the x-axis. That means they are trying to ask you to find the points of intersection of this graph with the x-axis. That means the x-intercept will be the solution to part C. In this particular question, I think many students were able to get a correct answer without knowing what's happening. Because they just quote the x-intercept. Now what if, after you manipulate, instead of 5 over here, this was, let's say, 4. Then our working will be slightly different, right? 4 minus 5. So instead of equal to 0, this will be negative 1. Then we will need to draw the graph of y equals to negative 1. Then we need to see where the graphs intersect. At y equals to negative 1, and this is y equals to x cubed over blah, 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 blah. Then we will need these two x coordinates. Okay? Must get the concept right. The approach must be correct. Now next, part D. Okay, please continue to look out for this. We are being very kiasu, because as y equals to x cubed over 20 plus 10 over x minus 5. So in pencil, as a side working, this is not for e-maths. We are just trying to secure as many marks as we can. This will be 3 over 20 x squared plus 10 over negative x squared. Okay, so this is 3 over 20 x squared minus 10 over x squared. Now they want the gradient at x equals to 4. dy dx when x equals to 4 equals to 3 over 20, 16 minus 10 over 16. Okay, calculator, which I didn't bring. How much is this? Can somebody help me calculate? Really? Oh, yeah, I brought it. 48 divided by 20 minus 10 divided by 6. We get 1.775. Now, I know that this is going to be the exact answer. But of course, you don't fake until your final answer for your tangent line has exactly 1.775 because it's next to impossible for you to really get this exact value. You know, your tangent line that you draw is an estimation. As long as you get really close to this, it's good enough. Okay? So your graph, let's see what the graph looks like in our work solution. Question, okay, this is the graph over here. Now, we know that they are asking for the tangent line at this point. So this is one of the coordinates, right? 4, what was it? 0.70. This is one side of the coordinate already. Our goal now is to choose another point in our x and y plane such that y2 minus y1 divided by x2 minus x1 will result in a value that is really close to 1.775. So it's a matter of working backwards. Okay? Now if 4 is over here, what is another x coordinate you would like to choose? You get to choose. Just like we draw tangent line, you get to choose points, right? To find the gradient. What would you choose? Okay, so if you were to choose the x-intercept, that means your tangent line is really tiny, right? If you were to choose 3, based on this, yeah, reasonable enough. If it is me, I will choose x equals to 6. So that when I find out when x is equal to 6, what has to be the y coordinate that will result in a straight line with gradient very close to 1.775. Let's say 1.8. That's my target, 1.8. Okay? So once I calculate, I reverse engineer, I work out the y coordinate, then I draw the tangent line, and then I find my gradient. And then, of course, it will be 1.7 because that is what I design it to be, or 1.8, depending on what you design your gradient to be. So all this for 2 marks. Is it a lot of effort? Actually, no. It doesn't take you long to just differentiate really quickly. Okay? Just be familiar with how you reverse engineer. Now, if you don't want to go through all this, you think you can draw your tangent line really accurately, fine, go ahead. Nobody's stopping you. Okay? It's just how desperate you are for that 1 or 2 marks. So the next part, find the coordinates of the minimum point. Part E, find the coordinates of the minimum point. Don't need me to tell you, you can also differentiate, set gradient equals to 0. And then you will see that the value of x, the x coordinate, is going to be very close to 2.9. Very close to it. So you can use that to check your answer. So this is how you can help yourself secure as many marks as you can. Final question that I want to go through, question 10. Again on the explanation. So in this question 10a, let me just write down the values. Over here we've got 37 marks for the median. And for the interquartile range, the interquartile range is 17 marks. In the box and whisker diagram, we can also find the median over here. This is 34 marks. And the interquartile range is 22. So we take 43 minus away our 21. So 22 marks. Make 2 comparisons. Standard way of answering. First, you compare the performance. Performance will be the median, comparing the median in this case. So in the first cumulative graph, this is for physics. And this is for chemistry. In physics, the median of 37 is greater than the median for chemistry. This tells me that the students perform better in physics, generally. So that is the performance. That is one comparison already. The other comparison will be comparing the interquartile range. Now, interquartile range will tell us the consistency. The smaller the interquartile range, the higher the consistency. So in this case, we say that since the interquartile range for physics, which is 17, is lower than the interquartile range for chemistry, which is 22, it means that students are more consistent in their physics compared to chemistry. Putting all of that together, I can go on to further say that they're consistently doing better in physics than in chemistry. Okay? Or you can leave them as separate. First, median, they are doing better in physics than chemistry. Secondly, consistency. They are more consistent in their physics than in their chemistry. So these are the 2 comparisons.